Hello, this is going to be my presentation on EQ6, which is servo motors and how they work. So a servo motor is a very precisely controlled motor. So unlike a regular electronic motor, these motors can be precisely controlled for specific purposes using computer, like CNC milling, which requires exact precision down to the millimeter, 3D printing, which requires the same, so they're basically more accurate motors. So electric motor works by, just a regular electric motor, works by having your battery. This sends the electrical signal into this brush. And the brush touches a commutator, which is an electrical ring, but it's split. One side is for the anode and one side is for the cathode. And it's on this pivot. Alright, in between it is a pivot. It's actually attached. So basically, the way it works is that connected to this is a coil. So this coil, it forces electricity to flow through this coil, and there's a lot of wire here, so it creates a big electromagnetic force. And that coil then connects back to the anode. Anode. And then the way the electric motor spins is that this coil now has electromagnetic force. So if you put it in between two magnets of opposite polarity, two different sides of the magnet, it's then going to spin. It's going to cause this part of the magnet to push the top of it away, but then attract the other side of it. And the south side is actually going to push this away. So it's going to continuously rotate this coil, and you can connect that to a pivot and get that force out of it. So a servo diagram. So how does actually a servo work? So a servo is an electric motor I just talked about, connected to gears, connected to a positioning sensor with a controller chip. So basically, in the diagram down here, you have the DC motor, and what's happening here is the DC motor is spinning the positioning sensor device, sends a signal to the amplifier to send a signal to the computer and tell how much it's spinning, all the facts about how fast the motor is spinning. This motor, based on the program that the computer wants to run, it's going to then send a higher or lower voltage or higher or lower length voltage pulse to the amplifier, which is then going to have that power to send a voltage to the DC motor and change its speed or direction. Now, keep in mind that the DC motor, the actual rotation is proportional to the amount of inputted voltage, so you can just control it just by changing the amount of voltage going to the motor. So AC versus DC servo motors. So I already told you about the DC motors. They're all controlled by the amount of supplied voltage. In AC, though, it's alternating current, which means it goes up and down the amount of voltage. So you need to understand the frequency of the voltage and how it's incoming and how it's going up and down, and you use that to control how much it's going to rotate. So AC motors, the better part of using AC motors is they can handle higher currents. So brush versus brushless motors. So brushless motors create more noise and are more costly, but are more reliable and efficient. Brush motors, on the other hand, are less expensive and simpler to operate, but require higher maintenance costs in the end. So brushless AC motors are most used, and DC motors are not really used that much. So basically, brushless AC motors are used the most, and brush DCs are usually used for cheaper applications, not that much. So this is my presentation on the servo motor and how it basically functions. So you have AC versus DC, brush versus brushless for the motor itself, and the pros and cons of using that in conjunction with the computer controlling device.